Tries. Tries means the a sorted tree, which is also called a digital tree or a prefix tree. The nodes are alphabets. Each node have multiple or single or no children at all. Real-time examples is text prediction, IP routing, sentiment analysis. So standard compressed suffix or the types of tries. Standard trie, which is a sorted or ordered trie, which includes roots and the nodes. Except for the root node, every node in the standard trie represents the alphabet. All children alphabetically sorted. For example, cat, car, dog, and doll means based on the chronological order, the elements are sorted. Three operations: delete, insert, and update. Time complexity is O of dm. M is the size of the alphabet, D is the operation string parameter size, and N is the string size. So standard for the set of strings. For example, this is an example. So beer means B is inserted. After that E. In that E we are having two strings AR and the LL. This is the example. So BID, that is a different one, and BULL and BUY, that is another one different. And S is the starting character, E and the T. In T we are having two things. One is OC and OP. So for the O, C and P is the parent and the K. This is the example. Compressed trie. Compressed trie, which is a compact form of standard trie. It merges similar prefix nodes of standard trie to a single child. The nodes of the compressed trie have minimum 2 children. So which helps the memory management. The space complexity is O of n. Basic operations are insertion and deletion. So in this example, the compressed trie is we can have two or more character in a single. So there A and R is a separate one. Here AR, LL and BID. If it is not a branched one, we can merge them into single. This is the compressed trie. So that is represented in terms of S of 0 to 9 is the number of strings in the trie. So if S, E, E in the sense, the first one is S, that is 1, 0, 0. And the second one is B. And the third one is, this first one is B, and next one is H, and third one is S. So S is initially 3 zeros, and B is the S of 1 starting letter, so 1 0 0. But H is the which is not comes under any of the things, so that is represented as the 7th node in the string list of strings, which starts from 0 to 3 length. So next one for the S, B, E. E is in the all the second nodes. Second node, which is BE, and 8 is also BE. So first index, and then it starts from 1 to 1. Okay, B is the first, and E is also 1 to 1. And if you are going for AR, AR is the first one is B, but from 2 to 3, that is a length. And for LL, that is the 8th string, so 2 to 3, that's why 8 to 3. And BID is 6th string, so first one is the string index, and second one is the starting and the ending length. ID in the sense 1 and 2. In this way, all those things are filled. For example, stop. So S is 0 0 0. TO is the third index, the third string, and 1 to 2. That is the TO. And P is present in the 9th string. The starting, there is a one single letter, so 3 comma 3. This is the representation. Suffix trie is a compressed form of a trie. So like bioinformatics and pattern matching, children store words instead of characters. Compressed trie which is constructed using a suffix trie. It is an efficient approach for substring matching. So dollar symbol is used in the path. So here suffix try is minimize. So E is a different one, but for the I we have mice, nemise. Nemise can also be stand included, and the ZE. So in the mice also we are having ZE, and nemise and ZE. So these are all the separate character. Everything is represented. So E is the last one, that's why 7 comma 7. But the mice is the starting index is 4 and the ending index is 7. The properties of suffix trie is suffix trie, which is n into n minus 1 suffixes of x. So O of n is the space. Insertion steps, which needs to start from the root node. First character a means calculate the index a minus a, which is 0. Second character n means n minus a, that is a root node, which is 13. And d, everything is subtracted and calculated. So for example, and in the sense a and d, at the same time a is subtracted with the first one and the n is subtracted and the d is not subtracted here, so new value t is added. That is the insertion. So DAD and do, that we can also do. DAD, so D is subtracted with the D for the second one, but O is subtracted with the A means there is different, so we need to add the new one. So computer on the internet are identified by a unique 32-bit, so that we can represent it in the suffix trie, which can also be used in the verb search engine. So each leaf of the trie is associated with a word and has a list of pages containing that word called occurrence list. So how we are maintaining the occurrences of information present in the web search engine.